8.2 notes, so now we have 2 steps with fractions and decimals as well. On 8.1 we focused on 1 step, just kind of the simple what we have to do next. So for example, in this one, okay, and if you're a steps person, I think solving linear equations is steps based. Okay, there's certain steps to do in a certain order to achieve the correct answer. Okay, certain things happen where there could be a negative negative or those little minor details that can make you miss things along the way, and that's the part about being accurate, right? So in this one, the first thing I want to say is I want to say that we have to understand that what's the goal? The goal is to get that isolated. We're trying to get x by itself. So knowing that, I do want you to realize this, I think is really important. The 2 things that are bothering us is the 1/10 and the 2. Right? 1/10 and the 2. So we have a 2-step algebraic expression. So we have 2 things that we need to get rid of. Okay? So in that case, I'm going to, correct. We go backwards bed mass, right? Whoops. Correct. So when solving, you're unwrapping a present, is the way it was explained to me before that made sense. So if I'm unwrapping something, I don't go normal operations, I go reverse operations. So that's why if you're saying, well, I thought you multiply divide first. No, because if you divide 2 here, you have to do it to everything. Now you can do that, it's just more difficult. Okay, so it's easier to go, like Luke said, minus 1/10. That's our first step. So we need a little separate spot here because we have to get a common denominator. So we need it because we can't just minus those, they're not the same slice. So we have to times this one by 2. So it's going to be 6/10 minus 1/10 is 5/10. Okay, 5/10 is 1/2, correct? You guys okay with that? So 2x equals 1/2. Okay. So all I did there was we did our common denominator over here. 5/10 equals 1/2. So I put the 1/2 right there. That's all I've done. Divide 2 to the last step to both sides. Okay. A couple ways you can look at this. If you do a whole number divided by a fraction, just so you know, it hits the bottom with multiplication. Okay, so it's 1/4. If you want to see why, it's because of this. If I go divided by 2, that's 2 over 1. What's the process? Yeah, flip and multiply. 1/2 times 1/2 is 1/4. So 1/4 is your solution there. Okay, we are going to check it as well. I'll wait for you. Just let me know when you're ready. Okay, so remember, we're going to take 1/4 and we're going to put it right there into that x. And the left side should equal the right side. So I do that, I'm going to have, we'll do that right here, 2 times 1/4 plus 1/10 equals 3/5. Well, 2 times 1/4 is 2/4. I'm going to add that to 1/10. Those have a common denominator of 20. 4 and 10 both go into 20, so I'm going to use that to get them to have the same denominator. So 5, 5, 2, 2. So then I get 5 times 2 is 10 over 20, plus 2 over 20 is 12 over 20. And 12 over 20 reduces to 3/5. So we just verified. Okay. this one here. Go ahead and try this one on your own real quick. I want to see how far you can get before you feel uncomfortable. Okay, so try this one real quick. Pause the video. Okay, so this one, I mean, if you get this one right, you're in great shape, like right off the bat. Okay, if you didn't quite get it right, that's okay. This is a pretty hard one. It's got a lot of things going on. Okay, it's got kind of the three things that some of you guys aren't going to like. You have one, you have a mixed number you have to convert to improper. Two, you have fractions. Three, you have the variable in a fraction. Okay, so there's three things that could slip you up there that you don't really like to do. Okay, the first thing you want to do is you want to get everything improper, okay, or to single fraction. So I want to get this into one fraction, okay, rather than mixed. So that's going to be, okay, that's going to be k over 3 minus 1/2 equals 1 times 4 is 4 plus 3 is a negative 7/4. Okay. Now we are to our two-step equation. We have to get the k by itself, so we have the 3's bothering us and the 1/2's bothering us. Okay, the 3 is dividing to it, the 1/2 is minusing to it, so going by reverse order, we will add the 1/2. Whoops, it's a 2 there. So that's gone. This is going to be negative 7/4 plus 2/4. If I do a common denominator, 2/4 is 1/2. Be careful with integers there. It's negative 7 plus 2. You owe $7, you pay 2 back. Okay, so you owe 5 now. Okay, so this would be negative 5/4. Okay, how many of you are still with me in terms of you got it correct so far? All right, that's okay. That's about where I thought we'd be, about 25%. Okay, so k over 3 equals negative 5/4. Okay, Blackie, how do you get rid of division? What's the opposite of division? Multiplication. So I multiply 3 to both sides, right? I multiply 3 to both sides. I put a 3 right here just to show that I'm doing it, and a 3 right there. This cancels, and you're going to be done now. It only goes to the top because it's 3/1. Okay, so if you got negative 15/4, good work. Okay, it's a good start. Any questions or confusions of things maybe you messed up on? Yeah.
I got the right answer, but I don't know how to check it.
How to check it? Okay, good. We will check it. That's hard to check it. Yep. Check with the number line. Yeah, it depends what you mean by number line. You have to get the number to put on the number line, right? So it kind of depends on, like, because I think the problem is people don't know how to do negative 15/4 over 3. So I'll show you. Yeah. Right. Yeah. So guys, to check it, negative 15/4 like over 3, and what Owen's saying is, can't you just put divided by 3, and that's exactly what you can do, which you'd flip and multiply. So what I've done is I've taken negative 15/4, I put it right there, and it's over 3, which means divide by 3. So when you do that, you flip and multiply. It'd be negative 15/12, correct? Because of 3 times the 4. Now you would go minus 1/2. And we're trying to get, and use the improper, we're trying to get negative 7/4. That's what we're hoping for here. We're trying to get that to be negative 7/4. 2 goes into 12, so that makes things a little bit easier. It's going to be negative 15/12 minus 6/12, because 6/12 is 1/2. Okay, and, oh, I see. Negative, oh, this is a negative up here. Why do I have that negative? I don't know, I had negative 15/4. Oh, because we got negative, right?
Yeah, it is negative.
Oh, it is negative. Okay, sorry. So that's negative. So then we get negative, okay, we're good. Negative 21/12. If you reduce that, 3 goes into 21 7 times, 3 goes into 12 4 times. So you get negative 7/4. So it does check out still. All right. Okay. So moving forward, this big show you know here, I'll do this first one, and then the next one you guys can try. So solve checking using fractions. So I'll try to, the boxes are kind of confusing, but we'll see if we can make it work here. 2, so this just means they're going to subtract 1/2. That's all they're doing here. They do it sideways for whatever reason. Okay, 1/2 in terms of force is 2/4. So then we get 3 minus 2 is 1/4. We divide by 2. We get 1/4 divided by 2 over 1. So we'd flip and multiply, which would be 1/8. Okay, so you should, down in that last box, you should get 1/8 as the answer. So in terms of what Luke said, in terms of using a number line to check, and what you kind of do is you have to kind of figure out, so here's 2y, here's 1/2, okay, and then 3/4. So how they figure that out is we know that this is 3/4, right? 1/4, 2/4, 3/4. This chunk of it is 1/2. And so what's left is our mystery. 2y is this piece. Okay? Well, if we know that these are halves, what's 1/2 of 1/2? And that's what we figured out. That was 1/4, right? Why did we get 1/8?
Because it's
2y, yeah. Gotcha. Okay? Does that make sense how they did a number line? So number line, they pretty much number line, just to give you like a quick, what they're doing is, your constant, right? Constant's a number without a variable. You pretty much just line that up to cancel the constant. So here's the constant, cancel that, and this is what's left. Yeah?
Are we ever getting into that on the test?
A number line, no, I think it'd just be a way to like check for yourself, but I prefer to plug it back in. I don't use it very much. Okay? All right, so we got 1/8. You guys try this one. A lot harder. All right, so they made it improper, so that was, a lot of you guys got 19. Okay, and what they're doing here is they're getting multiples, so you can write 2, 4, 6, 8, 4, 8. You can just do 12 if you want, and then 8 and 16, and then you'll see that all of them go to 8. And so you can use 8 as a common denominator like across the board. Okay, and so what I'm going to do here is, I'm not sure if this is what they did, but I'm going to go ahead and go 4/4, 2/2, and 1/1, because we don't need to multiply that one by anything. So by multiplying 4/4, I'm allowed to do that and not do it to both sides, because 4/4 is just the number 1. Okay, because times something by 1 doesn't change the number. Okay, so 4 times n, 4n, 4 times 2, 8, minus 2 times 3, 6/8, equals the 19/8. Now, I don't want to call this a trick, okay, but everything's over the same number, right? So 8, 8, 8. You can drop them. You can drop the 8s. Why? Well, because technically, if you do something to everything in an equation, to both sides, you're allowed to do that, right? So if I went ahead and said, I'm going to multiply everything by 8, what happens? Cancel, cancel, cancel. So now you're left with the nice 4n minus 6 equals 19. No longer fractions, and now you're to a little bit easier, prettier equation. Okay? Remember that for Math 22 if I'm your teacher, because we do that with our rational expressions. If it's all over the same thing, you can drop that thing. Okay? So now we just add 6. We get 4n equals 25. Divide by 4. N is 25/4. So not pretty, but that's what it is. Okay, and we'll move it down here and we'll check. Is there any questions on that? Okay, so they were all over 8. So we multiplied everything by 8, and they canceled. That got rid of your fractions. Okay, let me do the check here. So we have right here 25/4 divided by 2. So So that would be flip and multiply. So that would be 25 over 8 minus 3/4. Get a common denominator. 25 over 8 minus 6 over 8. So let me go too fast here. So 25 over 4, if you flip and multiply, that would be times by 1/2. So 25 times 1 is 25. 4 times 2 is 8. Then I got to get a common denominator here. 25 minus 6 is 19 over 8, and that's what we had here for its mixed, or its improper fraction. Any questions there? Okay, just got a couple more here. So we got a couple decimal, and then we got a little word problem here. Okay, so decimal, same thing. Nothing really changes. Okay, we have to get rid of the negative 2.5 first, and we're going to add that. A over 2.8 equals negative 1.2. And then we're going to times 2.8 to both sides. That's how we get rid of stuff divided by. So you go negative 1.2 times 2.8. So we have that. What's negative 1.2 times 2.8? 3.36. Okay. Yeah, thank you. Negative 3.36. Okay. It's a little easier to check decimals because you can just put them in with your calculator in terms of a calculation. So I'll just show you. You're going to put it in like this. Make sure you bracket. And then what I would do is I would do this calculation first because your calculator can be confused sometimes. Just go ahead and put this in. Once you get that answer, then hit the subtract button and subtract 2.5. And it'll subtract 2.5 to that answer. And that should get you negative 3.7. Okay. All right, one more little decimal show you know here, and then we'll have a couple word problems. All right, so this one again, it's just showing you the steps. Okay, so plus 3.3 minus 3.3 to both sides. 1.8 minus 3.3 would be a negative 1.5 times 1.6 to both sides. Okay, if somebody's got that, let me know. Negative 2.4. Okay, so negative 2.4. And now we'll check that by plugging in 2.4, negative 2.4 in for h. Remember, calculate this separately and then add 3.3 to it. Okay, and then that should get you the negative, or excuse me, that should get you 1.8. All right, now for the hard part, setting up an equation based on like a word problem. Okay, so putting together an equation that you need to solve based on what they give you in words. People always look at that and freak out. Oh, word problem, hate it. Okay, but just get to the information. What do you need? Okay, so let's see here. Colin's telephone plan charges 5 cents a minute. I'm just writing through. When I read through, I'm just going to underline, highlight stuff that I think is going to be important. So they charge 5 cents a minute. Okay. There's also a monthly fee, $4.95. Okay. Colin's long distance charges for 1 month was $18.75. How many minutes long distance call did Colin make that month? So what you got to ask yourself is identify the variable. What is the variable? What's that? Like what's the variable represent? So not a number. Yeah, Aiden?
M could represent minutes.
Long distance minutes, right? And you know that that's what the variable is because they're asking you to find that. They're asking you to find how many minutes of long distance calls. So that's your variable. That's the unknown value, right? Okay, so then now we got to form an equation. So we know, based on what they've told us, it's something minutes plus the monthly fee. Okay, I don't want to use Y here, sorry. We'll use C for cost. So it's something minutes plus the monthly fee equals cost. Okay, so what is the charge per minute? 5 cents. So you should have 5 cents next to X. Okay, so you should have 0.05. You can put M if you want, but I'll put X because we have it right here as X. 0.05X. That means 5 cents per long distance minute. It's multiplication. Okay, we also know the monthly fee is our constant. Why is it our constant? This is where the definition of the word constant sticks out. Yeah. Because it's there every month. It doesn't change. It is constant, right? It's a constant value. Doesn't matter if it's February and it's a shorter day a month. It's every month it's going to be $4.95. Okay, and then we know he spent $18.75 or was charged $18.75 one month. So what we can do is we subtract the constant and then divide to figure out how much he used of long distance. Okay, that'll give us the minutes. So here we go. We're going to go minus $4.95. Okay, so we got a 0, 8, 3, 1380. Okay, so we take 1380 and we divide that by 0.05. Is it 276? Yeah, 276. So you had 276 minutes of long distance. That's a lot. Okay, over 4 hours of long distance calls in a month. Okay. Today would not be 5 cents, I don't think. Yeah, probably. Okay. All right. Okay, try this one on your own here. Okay, so Colin charges cheaper long distance plan. This plan's 4 cents a minute, but a monthly fee of $3.95. How many minutes per month of long distance calls can he make for $18.75? So the total cost for the month, that's just rewriting what they just told us, is $18.75. The monthly constant fee is $3.95. The cost per minute is 4 cents. Okay. Let M be minutes of calls. So there you have the 0.04 in there for you. We put in the monthly fee of $3.95 and how much he can spend. And then we solve. Okay, yeah, so we minus $3.95. So that's gone. 0.04 M is the 15 or 1470, you said? 1480, okay. 1480 divided by 0.04. And oh, that's the 370, gotcha. Okay, so then your sentence here, he has 370 minutes of long distance calls he can make in the he has 370 minutes of long distance calls he can make in order to be under budget of $18.75. Okay. Your check, just plug it in. I'll let you guys do that, but you guys get the drill.